Okay, so today, this is our week 3 lecture, and last week we talked about the kind of hierarchy or the objects that exist in Revit and the hierarchy. And if you remember, the hierarchy that I described back then is at the top we have category, and then underneath we have family, and then under that we have type, and under that we have instance. All right, so the category lets Revit know what this thing is. Are you a wall? Are you a door? Are you a window? And then the family starts to describe kind of the behavior of that particular object and how that particular one is going to behave. So today I want to talk a little bit more about the family and its kind of role within Revit, just so we get an idea or a better idea of what I'm talking about when I use the word family or when I'm talking about families, because really everything we work with in Revit is a family. So it's important to understand exactly kind of what that is and how that affects what you see on the screen and how you design things with it. So if you think about a family kind of at its really simplistic, easy to understand level, and we'll get into it a little bit more here today, but the most simple and basic understanding of it is really it's kind of a group of types. So for example, when I say types, in this case I'm meaning sizes, but it doesn't necessarily have to mean that. So for example, I have a series of windows here that are just fixed windows, and then I have a different family over here that is some casement windows. So if you think about it, really this family, and I'm going to go to my family browser here and I'm going to look at it. So this family, this window family, is really just a collection of types. So you see I have 2 windows here. Maybe I'll make this a little bit bigger so we can see it for now. So this fixed window family, has a collection of types inside of it. So it has a 16 by 24, that's probably what that one is, and then this one is, I'm not sure what size that is, and then this is probably that 36 by 72 window. So it's a collection of, or a family is a collection of these different types that exist. So all of these types are available to me. So for example, if I wanted to change this window to be a different type, I could come up here to my type selector, and so it is a 16 by 24 window. If I want it to be a different type, I can choose that and go down my list of types and say, oh, well, I really think that needs to be a 24 by 48 window, and it'll make the change for me. So the family is an element or an object that is holding kind of the instructions or the descriptions of it. So, and the same goes for these casement windows. So in this case, the casement windows, I happen to only have those 3 types that exist. So the fixed window has many more types, and the casement window right now only has a few types in it. So, but the same would apply, that I can select that thing and I can switch it out for another type, and then it will change. Or I can even switch out that window family for another family that's the same category. So I talked about this last week. You can swap out pieces for another category. So if I decided I wanted this window, it's not supposed to be a casement window, it really is supposed to be a fixed window, I can swap that out and it'll make the change for me. So you can swap these things out and move them around. So I'm going to get this one back to the way it was, what I want it to be. All right, so that's the basic idea of a family, is that it's this collection of types, and these types are groups of parameters that somehow describe what that item is. This behavior, this change, is also part of that. I talked about design intent, for example, last week, and I talked about relating roofs to walls and things like that, and I've talked about it a few times probably. But say for example, design intent, this casement window, the design intent of this is that it's supposed to have a 3 by 3 grid in it no matter what. So no matter what size I make this, so when I make this into that larger size window, the grid work remains the same. It's equalized across the width and equalized across the height. So there's instructions within that family that contain that design intent. So this is one of those ways that Revit keeps that design intent, is that it's encoded into the actual family itself. So no matter what size I make this window, the fact that it will remain equally 3 across and 3 in the height direction, that will always remain the fact, because that's part of the instructions within that family. So building the family, you also have to understand about how the relationships are made. So if I wanted to make a different, maybe a prairie style window that had, move that mutton up here and move the mutton down here, so they weren't, so it was not the same, they were equal on the top and bottom and a different amount through the middle, I would have to rework this family. I would have to change that family in order to do that. There's no way for me to individually go in and grab a mutton and move it accordingly. So I have to understand how that family works. Let me switch that back again to that smaller size. So, and there are kind of 2 levels of family that I'll describe here too. So these windows and these doors, these are loadable pieces of content, or loadable families. So if I wanted to place another one, and say I wanted to place a double hung window, so I come up here to the window command, and let me cancel on that, and I want to place a double hung window, so I select here, and I don't happen to have a double hung window. I only have casements and I have fixed. So in that case, I can go out to a library of things and I can bring something in. So I'm going to load a family while I'm in this window command, because I haven't found the one I want. So I'll load a family, and I'll find, in this case, now I'm looking for the category, right? I want to make sure I wanted windows, so I'll look for the category windows. I want windows, and I want a double hung window, so I'll grab that, or maybe I'll use this double hung with trim, and I'll open that up. And now you see, now I have a double hung window, and it, of course, has a certain collection of types, just like the other windows do. So I could choose a different type. I could choose maybe the 36 by 24, and I can put a double hung window here, and I can put a double hung window here. Right? So there are loadable families that we can bring in from outside of our project. And then there's another classification of families that Revit has, and these are called system families. So, for example, a wall is a system family. When I initiate, let me go to a plan view so it makes a little more sense. If I go to a plan view and I start the wall command, here I don't have the load family. I can't load that category because this is a system family. Now, it still has a collection of types that I can get to. So if I wanted to place a different type of wall, if I wanted to place a brick wall, let's say, and I place that thing here, maybe I'll make it stick out from beside the edge here so you can see the difference once we go back to the elevation. So if I place this brick wall in there, I'm going to go a little bit longer. So you can see it has a different hatch pattern than this one, and if I go back to that elevation, there's that brick wall sitting out there behind. So system families are families that are defined only within the project. You can't get them from a library somewhere else. So if you have a bunch of walls that you typically use, you would have to kind of maintain them within your template project, or maintain them in a place where we can transfer them from another project into our own project, or cut and paste from another project into our own project. But we can't load the individual system families themselves. And system families, there's a bunch of different ones. I discussed walls, but roofs and floors and a number of other things are also system families. So typically the host type objects, so you can host windows into walls, or a roof can be a host for things, or a floor could be a host for things. Typically the hosts are system families. That rule doesn't always apply, but one way to know whether you're working with a system family or not is if you select one of them, and when you press the edit type button, it will say system family. So if it says system family, you know that you cannot get that from some library location. You're going to have to modify or make one yourself within this project, or cut and paste, or do something like that. So the important thing to know is that there's loadable families and system families, and those are 2 different kinds of things. So that's kind of the basic rundown of how, the kind of idea of families. So let's talk a little bit more in depth, because I talked in my hierarchy, we had the category, family, type parameters, and instance parameters. So let's talk a little bit about kind of the type parameters and instance parameters. So if all of these things, every single object has some type of parameter. So if I select that, let me make this a little bit smaller now. We don't need to look at that so much. So once I select an item, what I see in my properties palette, that is the actual instance parameters. So these instance parameters affect how that item appears. So if I say change the sill up to 3 feet, that item will move up higher into the wall. So these instance parameters, they're only affecting that one instance of the object. They're having an effect on that particular one, and doesn't change any of the other ones. Now, at the other level, at the level right above that, are the type parameters. So to see the type parameters on an element, they don't immediately show up when you select one thing. And even if I select multiple of these things, I'm still just seeing the instance parameters that are common among these things. So I could use something like that to change all of their sills to, 3 feet or whatever, and they would all match. I'm going to undo that. I want them to kind of be setting apart. So anyhow, you're not going to see instance parameter, or you're not going to see type parameters. The way you access or see the type parameters that are here are when I press edit type. So now I have a list of the type parameters that are in here. Now type parameters are something that are a little bit more powerful than instance parameters, because when I make a change to a type parameter, instead of, like in the past, when I changed that window sill height, it just moved that window up. It didn't have any effect on this window down here. Well, these two windows are the exact same type. So now if I made a change to something here, that will affect both of these. So let's see how that works a little bit. Let me switch this to a shaded view. Let's see if that'll work. That'll show us what we want to see. So I'm switching to a shaded view so we can see the material that is used on the frame of these windows, because I think that's something that's applied at the type level, and I think I can change it. So when I select that, there's nothing here about the frame material there, but if I go to the edit type dialog box, I have sash material. It's not frame material, but I have sash material. So it's using a material called sash, and probably all of these windows are all using the same material called sash. But if I made a change to that, and now remember, I'm affecting the type 36 by 72. So this window and this window are going to be the ones that change. These windows, and of course these casement windows, because they're a totally different family, all of those should remain unchanged when I change this sash material. So let's change this. And once it comes up here, so let's change it to something like, let's see, do I have aluminum? Whoops. I have aluminum. So let's select that. So I'm changing it to aluminum, and so it should change to use this color that's much more white. So we had a brown looking window before. So now when I say OK, now it's using aluminum for the 36 by 72 type. And now when I say OK, both of these windows changed. These ones, even though they're the same family, they were unaffected because they're a different type, right? This one is a 24 by 48 type. This is the 36 by 72 type. So changes at the type level, type parameters, when I change them. So if I select that again and switch it back, changes at the type level, I'll switch this back to sash, and we'll see it switch back. So see, there's the brown color that it's going to use in this, wooden rendering appearance. So now when I say OK, it's using sash again, and OK, and now they switch back to use sash. So changes at the type level affect many, many objects. So however many of these I had in my project, it would change them all at one time. So the type parameters are very powerful, so they can be kind of dangerous because you can make a change that you may not necessarily see. So knowing whether you're changing an instance or a type parameter is kind of important, right? So let's say that I don't know that I would ever need this, but well, actually, let's say that I have this window here is a 24 by 48, and I would like this window here to also be a 24 by 48. I want a 24 by 48 window that's a casement window to match this window over here. I need the same size. So to make a change to these, I want these to be 24 by 48. I come to my type selector and I find I don't have a 24 by 48 window. I have a 36 by 48 or I have a 36 by 60, but I don't have the 24 by 48 that I do in the fixed window that I want to match. So in this case, this is a situation where I actually have to make a new type. So with whether you're working with system families or whether you're working with loadable families, making new types is actually a pretty similar process. So what we do is we kind of spawn new types from an existing type. So you find something that's kind of close to what you want, you spawn and make a new one and make some changes to the type parameters so you get that new type. So we've already showed changing type parameters. We were changing from sash to aluminum, but now we're going to change the size of the thing. So let's pick one that's close. So the 36 by 48 is close. So I'll change that, and you see it change over here. But I wanted a 24 by 48. So in order to get a 24 by 48, like I say, I start from something close, and then I'm going to edit the type. And when I'm in the type properties dialog, I don't want this type. I need a new one. So I'm going to use the duplicate button here. So I'll click that. And I'm going to give it a new name. So I wanted a 24 by 48, so I'll give it a 24 by 48. And the name is really just a name. It's not anything other than text. It's not actually, you could change these values and it doesn't realize the change. So the name is just what you give it. So you have to be pretty explicit. So now I've changed to a 24 by 48. So now I want to go down here and I want to make a change down in here. So I can change, the height is still right, 4 feet, but I need the width to be 24 inches. Here it says 3 feet. I can type in 24 inches. I could type in 2 feet, whatever. It doesn't really matter. It'll both will work. So now I have 24 by 48, and I have the correct type, so I can say OK. And now it makes that change. So now this window is the same size as that window. So now I have this new type available to me. So I want to make this one, I want to use that one and change it to the 24 by 48. And now it's listed in my type selector, so I can choose it. So instead of just those 3 that I started with, now I have a new type for my casement windows. So this is a way that you can kind of spawn and create new ones. Now it's really a pretty good idea typically to do a duplication and then edit, because you never know when you need that type again, especially when you're working with system families. So rather than just coming in here and grabbing one, edit type, and then just changing the values down here and maybe even doing the rename and changing it, I like to be less destructive and keep those old types around until I know for sure I'm not going to need them. So I usually do duplicate. That's usually the first move that I do, rather than just changing things and renaming them. Or even a lot of times when people are first learning, they'll forget this duplicate thing and they'll come down here and they'll just start changing numbers down here. And when you change the numbers down here, it affects a bunch. So, for example, if I forgot to duplicate first and I just started doing something down here, so I changed this, I changed the height for whatever reason to, 6 feet, and I hit apply, right? It changed both of these windows. Even though I didn't mean that to happen, it changed 2 windows because I was just trying to change the size or get a new type, and all of a sudden I've changed windows in a lot of different places. So I'll cancel that out. I don't want that to happen or undo that here. So you have to be careful when you're making new types is to make sure to duplicate first so you don't wreck work that you've done somewhere else and you may not necessarily see directly on your screen. So just be careful when you're duplicating types. All right. So that gets to, why would I choose type parameters versus instance parameters? Because actually when you make the family, there's no reason why I couldn't have put the window size as instance parameters in here. It's really something that's up to the person who makes the object, who makes the family. They can make these parameters type or instance, whichever. So one of the kind of rules that you follow is that type parameters are usually related to the kind of intrinsic properties of that element, and instance parameters kind of related to external things. So in this case, it makes sense to have a sill height of an instance parameter, so we can change the sill height. Maybe we want all of these windows, we probably want their window heads to align. So if I select, how about if I only select the windows? Select the windows, and I can set the head height all at once, and that's fine. But maybe I don't want that to happen over here because this little window wouldn't ever be cut, or maybe I do want it high. But the idea is I can control individual windows. I don't want to control the sill height on a kind of global scale typically. I usually want to control those one at a time. Or another example of using instance parameters is, say, these door handles on here. These door knobs or door levers happen to be an instance parameter that's called hardware set. So I can switch them out. It's very subtle, but this handle is now different than this handle, right? And hardware is something that's pretty typically, different doors, maybe not the shape of the handle, but they certainly use different lock sets. So if you were keeping track of lock sets on a door with a hardware grouping number or something like that, where a classroom has one kind of lock, a storeroom has a different kind of lock, and the entry door has yet a different kind of hardware set that is on that door. So every door is individual, but they could be essentially, they both could still be wood single flush doors. So you want to think about how that parameter affects kind of how you're using that or what you're using that parameter for, on whether you choose to make it an instance parameter or whether you make it a type parameter. So just remember, instance parameters have effect on only that one place. So I changed the door handle. None of the other doors, even though they're all the same family, they all have that same door handle. Now if I make a change to a type parameter on this door, say for example that frame material, if I change that out to be aluminum again, so and I've changed it at the type level, so all of the doors made that change. So type, very powerful, changes many things at one time. Instance changes just the one. So when you're deciding between the two, that's a good idea to kind of think about that relationship. So really the family, to get back to what I started talking about, the family is really a storage container, if you will, that describes, I'm describing the geometry of the thing. So this is what it looks like in elevation, or this is what it looks like in elevation and plan, etc. So like if we went and looked at the plan, right, the casement windows here and the fixed windows here look essentially the same, but in elevation they look different. So that's the whole, that's kind of what the role of the family is. It describes the geometry, but it also describes the set of parameters that you're working with. So say the type parameters, what you're using there, or the instance parameters, what you're using there. So the family is a gathering place for all those kinds of instance things, all those kind of type things, and the geometry. It's kind of the, if you will, the DNA of what that thing kind of is. All the parameters, all the geometry, everything all captured into that one object. All right. And another kind of powerful concept here, which is being used in this case, is that you can nest families together to create something. So we have a door family here that then has this handle family. So this is a whole other family that I'm swapping in and out. So if I wanted to change the idea of nesting families together is pretty powerful, because I can all of a sudden have one family description in my project, and then if some change comes along and I can change the nested family, and it will change everything in my project all at one time. So that's another way to affect massive amounts of change, is with nesting of objects. So now we've talked a little bit about what the role of the family is. I'm just going to describe a little bit more about actually the parameters themselves. So we talked about changing parameters and that they do some things. So that's really, a lot of what parameters are really there to do, is they somehow describe the behavior of these elements. So in this case, I was changing the size of the thing, right? So it changed how that's going to move, or what size it's going to show up. Or I've also been changing the material property of this thing. So that's another way that you can affect behavior of the, if you will, of the family. Or in this case of the door handle, I was describing which a family it's going to use as a parameter. So parameters affect the behavior or the relationships of these things, of the elements within the family. So that's really what they are, is ways to control what we're seeing. So parameters themselves actually have property types too. So if I let's look at one of these windows. So let me edit. I actually want to, in this case, I don't want to edit the type or the instance, because I want to describe a little bit more about how we make these different parameters, right, and what they all are. So we know that they affect the geometry in some way, but I also want to know something about these parameters. So let me actually edit this family so we can look at that a little closer. So here's the family, and if we looked at it in plan, we could see some of these rules around how the geometry is being controlled, and you start to see some of the things like width. Well, that's one of those parameters, right? Or if I look at an elevation, probably on the exterior, I'm going to guess, here's height, and the default sill height, and the trim width. All of these things, all of these parameters are showing up in this description of the family. So let's look at the parameter. I think that's what I want right there. So in the family dialog box, now I see these are all of the parameters that are controlling. And if I was going to make a new parameter, the parameters themselves actually have types. So am I going to be keeping a length in there? Am I going to be keeping area? Or am I going to keep materials? Or the other one that I used was family type. So parameters themselves have kind of what value they're going to hold and control. This helps Revit determine what to do with that information and how to display it and those kind of things, and the kinds of relationships it can have. You can store just texts. You can store 1, 2, 3 actual numbers with decimal points, those kind of things. Money you can keep track of, but you have to let Revit know what parameters, what kind of parameter or what kind of information you're going to be tracking with a parameter when you make them. So know that all these have different values in here, and this looks like it's just text, but it's really a material parameter, right? Because I want to be able to select materials from within my project once it's there, so I can change that. Okay? And parameters in some cases, so let me get out of this. We've seen what I want to show there. So let me close this out. So in some cases, a value for a parameter is really kind of a primitive value, right? So in this case, the height, it's just the raw height, or the width is just the raw width. That's kind of just a really primitive kind of understanding of what a parameter value can be. but they can also have complex kind of relationships as well. So if I close that out, so an example of a complex relationship is, say for example, the sill height is listed as 3, but 3 from where? Well, it's 3 from the level, right? So it has this more complex relationship. So this window, for example, is level 2 and it's 3'3", but I could change this value, say to be related to level 1, and it has a sill height of 12 feet maybe, and move it up there. So now this has kind of a different relationship, right? This one is related to level 1. This one's also related to level 1, but its sill height is different. So it has this kind of like maybe a nested relationship or a more complex relationship. But this can kind of be a little bit confusing because, you know, if you have one, say you have one window that's messed up like that, and you go and you change, so here's level 2. So these windows here are related to level 2 like they should be. This one here somehow got messed up and is related to level 1. So if I change level 2 and move it, you can see all those windows move, but that one stayed put because it's related to level 1. So there are these kind of complex relationships, so you have to make sure you know that these constraints or these parameters are all set the way that you want them to be. Whoops, I switched it to level 1. I wanted it to level 2. Now it's outside of my wall. So anyhow, that's the idea, that there are these complex relationships that can exist between these elements. And oh, that's why I need to change to level 2, but I need to set that back to 3 feet or something. So there are these kind of simple complex or simple relationships of 1 to 1, and then more complex relationships of, you know, a level plus a parameter create the actual condition or the position of the thing. And so that brings up, you know, you need to have kind of default values for these items that make sense and in the correct places, right? And so there is also kind of these relationships besides the simple and complex. There's also a relationship where the complex and the simple that I've been describing are kind of explicit changes. I change the size or I change the level and it moves where it's supposed to be. But they're also kind of implied changes as well. So for something, say like, let me go to a floor plan to describe this kind of implied parameter change rather than an explicit parameter change. So an example of kind of an implied parameter change is, say, oh, actually, I can do it from the front view. Let's do this. So an explicit change, let's say this wall, I can explicitly change it to be 25 feet high, and that wall goes to 25 feet high. Now, that may be the way you want to control it, but you can also do something like this. I can, instead of making it be an explicit relationship, I can say, you know what, I really want that to be just to go up to level 2, and I actually don't care what the actual height is. I just wanted to make sure it matches level 2. Now when I do that, now the height value, I can no longer explicitly place a value in there. So now it's tied to level 2. So wherever level 2 goes, the top of that wall will also go. So we can build these kind of implied relationships, or rather than having an explicit value. Another example of that, let me go back to my floor plan, is there are some kinds of elements that we have to make a sketch for. And when I say sketch, it's kind of a visual parameter, if you will, of an element. So say a floor. When I create a floor, I go into this what's called sketch mode. And so my properties, or my ribbon, I can only do sketch the outline of the floor, or I have to cancel or finish it. I can't do anything else until I'm done with that. So I can draw an outline for what my floor is going to be, the shape of the floor is going to be, and I'm not specifically defining a width and a height or anything like that of the floor element. I'm just describing the outline. So the actual shape or the dimensions are somewhat implied, right? So it has some type of perimeter, and it would never list a width and depth because it doesn't know what directions I'm talking about. But this kind of sketch relationship is somewhat of an implied kind of behavior that, and sketches are definitely really just visual parameters, right? I don't put them in over here in any way. I have to sketch them here, and then it interprets the shape from that, right? And I think that's where I can kind of wrap it up. So now we've talked today in this lecture about kind of what a family is, right? So we know that a family is the container or of the DNA of that thing. So the geometry, the parameters, everything that describes that item is what the family is, right? And we kind of have two levels of how we control families. Is we can control them at the type level by changing type parameters or duplicating and making brand new types, right? So we start out with a list of 3, but we need 5 different sizes. We can duplicate and change them to the what we need. Or we have the instance properties on things. So if we need to change individual items, we can, change an individual item by resetting its, sill height or whatever to be 3 feet. Move it where it needs to be. It doesn't affect this one over here. So that's another way to control is instance properties. Now, whether it's an instance or type property depends on how the author wants to define that. And then all of these parameters, of course, they kind of have these different kind of relationships, whether they're implied or direct or have kind of a complex relationship where a level has to exist before the item can exist, because its sill height is, in the case of a window, its sill height is directly related to the level that it exists upon. So that kind of covers at least the idea of families and the idea of parameters and how they interact with each other, and it starts to help you understand how to control kind of the geometry of the families themselves rather than just assembling the pieces that you have. Because inevitably you're going to have cases where you have pieces that you need from somewhere else, or you need to create new pieces. So starting to understand how families work and how parameters work is an important part of figuring out how to get these extra pieces that you need. So until next time, thank you.